Conditional probability. First, let's talk about the independent events. So, independent events occur. The occurrence of one event does not affect the probability of the other event occurring. So, they are two independent. One does not depend on the other. For example, if you toss two coins, the outcome of one coin is independent of the outcome of the other coin. Or if you roll two dice, the outcome of one die is independent of the outcome of the other die. Because we can toss it totally separately, they do not depend on each other. Let's call it independent events. Now, if we have two independent events, event A and B are independent, then the probability of event A and B is probability of A times probability of B. We simply multiply those probability. Let's see this on example 1. What is the probability of rolling an even number on the first die and a 6 on the second die? So on the first die, probability or all rolling an even number, we can have it 2, we can have it 4, or we can have it 6. So there is 3 possibilities. So probability of getting an even number on die 1 of the first die would be 3 out of 6. 3 out of 6. So this one is 1/2 divided by 3, right? If we divide by 3, so we have the chance of 1/2. That's my first event. Now probability of B, the second die we roll only 6. So there is only one event there, it's 6. Probability of B would be 1 out of 6. So then probability of A and B would be my 1/2, or let's do it first, the 3, 6, because we can see it 3, 6 times 1, 6. And in that case would be 3 out of 36. And we have it this, we can reduce it, divide by 3, would be 1 out of 12. And this we also could list all possible outcomes for rolling two dice. We know that the total number of rolling two dice was 36, if we remember putting this in the chart. And then if we roll it, that we have an even number and 6, even number and 6, even number and 6, we're going to have only 3 possible outcomes. So that should also perfectly make sense. Now we can use them as independent event and use this formula. Example 2. The probability of getting false positive for tuberculosis is 6 out of 100, or 6%. What is the probability of getting a false positive twice in a row? So those two events are completely independent. So then probability would be that we're getting 6 out of 100 times, that's my first test, on the second test would be 6 out of 100 because we multiply those events, right? Or we can list it as 0.06 times 0.06 as well. If we multiply them correctly, we should get 0.0036. So this is very small chance of getting the false positive twice. Example 3. In a bag, there are 4 yellow balls, 3 blue, and 5 green balls. You draw one ball and put it back. You draw another ball and put it back. You do it one more time for a total of 3 draws. What is the probability you will get a blue ball, then a green ball, and then a yellow ball? So all of them, because we put the ball back, all 3 events are independent. They do not depend what you draw the first time. on this the second row, right? So then we have the probability of getting, so then our probability would be equal. What is the chance of getting blue ball? How many blue balls we have? We have 3, so we can take this or this or this. So we have 3 chances out of total number. So we have 3 chances of getting blue out of total number. How many we have it? Let's calculate the total. Total number of balls we have 4 plus 3 plus 5. So 7 plus 5 is 12. So we have total of 12. So we will have 3 out of 12. So this is getting the blue ball from the bucket, because we have three balls out of 12 balls total. Now, then we getting green ball. How many green balls? We have 5, so we can choose one of those 5s. So we have 5 choices. So we have 5 out of total number of balls is 12. And then we can multiply. For choosing the yellow ball, how many yellow balls we have? We have 4 out of total choices, 12. So because all the events are independent, we can multiply them out. And then we can either multiply this out or we can try to reduce. 3 times 4 is 12, so that can reduce with one of the 12s. And the rest we simply multiply. So on the top we have 5. And on the bottom, 12 times 12 is 144. So this is the probability. If you're using calculator, you're probably getting 0.03472 something something. So this is 0.034 or something like this. Conditional probability. When we compute the probability of event A, assuming that probability B has already occurred, we call this conditional probability of A given B. In that case, this probability will be denoted P, A given that B has happened, or A given B. Then the conditional probability is if both probabilities A and B are equally likely, then the probability of getting A given B then is equal to probability of A and B divided by probability B. So we kind of think A and B divided by this what is on the bottom. From this formula, we can also get the other formula. I'm going to rewrite probability of A given B is probability of A and B divided by probability of B. Probabilities are numbers, so we can multiply this times probability of B times probability of B. This and this cancel out. So that's how I'm getting that probability of A and B is equal probability of A given B times probability of B. So this formula comes from rearranging the original formula. So I rewrote the conditional probability and let's see example 4. Anna took 2 tests. The probability of her passing both tests is 0.7. The probability of her passing the first test is 0.8. What is the probability of her passing the second test given that she passed the first test? All right, so we have probability of passing test 1 and test 2, let's call it T1, T2, probability of passing test 1, both tests, is 0.7. Then probability of passing the first test, so probability of test 1 passing is 0.8. Now the question asks, What is the probability of passing test 2 given that she passed test 1? So probability of test 2 given that she passed test 1. According to this formula, A given B would be P of A and B. So we have my T2, T1, probability of T2 and T1 divided by the probability of what is on the bottom. So probability of T1. I hope we see that probability of T2, T1 is the same as probability T1 and T2, because that's exactly the same. So then we have it 0.7 divided by 0.8, and if we divide this or multiply, we're getting 7 over 8, or if we type this on calculator, 0.875. So probability of getting of passing the second test, given that she passed the first, would be 7 out of 8. Example 5. At a high school, the probability that a student takes computer programming and Spanish is 0.25. The probability that students take computer programming is 0.45. What is the probability that the student takes Spanish given that the student already took computer programming? So computer programming and Spanish is 25. So probability, let's call it C for computer programming and S for Spanish. C and S, computer and Spanish, is 0.25. Now, the probability of just computer programming, so probability of C is 0.45. We are asking what is the probability that the student takes Spanish given that he took computer programming. Probability of Spanish given that computer is already taken is equal to, we're going to use it according to this formula. Conditional probability A given B is P at A and B. So in that case, we have probability of S and C divided by P at C. So this is divided by this bottom. S and C is the same as C at S. I hope everyone can see it. So this is P at C and S. So this is equal 0.25 divided by 0.45. So we have S is right here and C is here. And then when we divide those ones, we are getting that this is equal to 25 out of 45. We can divide this by 5. So this is equal to 5 out of 9. And that's my probability, 5 out of 9 chances. Example 6. The data in the table below show the results of survey used to determine how many times students ask for help. So full-time students that ask 0 to 11 times for help is 11. 11 to 19 times for help is 25. 20 plus is 8. And the total. And then part-time are listed here. So what is the probability that a person selected asks for help less than 10 times given that the person is part-time student? So we can have it probability of A given B is equal to probability of A and B divided by probability of B. So my probability of A is selected students ask for less than 10 times, and B is part-time student. So 10 time and part-time student. Part-time students and 10 times is 4 out of 60. So we're gonna have it 4 out of 60 for the first top probability. So my A is asked less than 10 times, and my B is part-time student. My B is part-time students. So we have part-time students and ask less than 10 times. So it's 4 out of total number of students. So this is my probability. Now part B, person is part-time students. So we need to check how many part-time students we have. We have 15 out of total number. So this is 15 out of 60. And this we can solve it that this is 4 out of 60. To divide by a fraction means multiply by its reciprocal. So we multiply times flipping the second one, which is 60 out of 15. And then the 60 and 60 can reduce. So we have that this is equal 415. So this probability is 415. For part B, we have what is the probability that a person selected is full-time given that it's asked for help more than 20 times. So in that case, we have probability that the person is full-time given that ask for 20 or more, so 20 plus times. So this would be probability of full-time and 20 plus times divided by probability of 20 plus times ask for help. So full-time and 20 plus, full-time and 20 plus is 8 at probability, so 8 out of 60. So this is equal 8 out of 60, all divided by, now we have probability of 20 plus. How many 20 plus we have? We have 14 out of 60. So 14 out of 60. And that gives us 8 out of 60 times we multiply by its reciprocal on the bottom. So we have 60 out of 14. And then as before, 60 cancel out. So we have 8 out of 14. This can be divided by 2, so it's 4, 7. The probability of part B is 4, 7. This we divided by 2, we divided by 2. Now we have probability 3. We can represent an experiment that happens in stages with a tree whose branches represent the outcomes of the experiment. We calculate the probability of an outcome by multiplying the probability along the branch representing that outcome. So this is called probability tree, and we can see it on the example. So example 7. If you are heading to a soccer practice and you hope to be a goalkeeper, the coach determines your chances. So if coach Sam is present, the probability of being a goalkeeper is 0.5. If coach Alex is present, the probability of being the goalkeeper is 0.3. Coach Sam coaches 60% of the games, so that means a probability of 0.6. Draw the probability tree. So we're gonna start like this. We have coach Sam and we have coach Alex. Now, the chances that coach Sam is there, coach Sam coaches, is 60% of 0.6. So we're gonna write 0.6 on the branch of that tree. Now, always, so if coach Alex coaches 60% of the times, that means the rest coaches coach Alex. I'm sorry, the coach Sam coaches 60% of the time. That means the rest 40% coach Alex is coaching. So we have 0.4. It's worth to notice that total numbers of those two branches need to add up to 1. So this needs to be total 100%. So if this is 60%, this needs to be 40%. Now, from Sam, we can be goalkeeper G, or we might not goalkeeper, so that would be not G. So now what are my chances? If coach Sam is, then the goalkeeper is 0.5%. So we write 0.5 right here. So this is one more time. Coach Sam is present, and then your goalkeeper is 0.5%. And so both of them needs to add up to 1. So this is 0.5. This needs to be 0.5 as well. Both of them needs to add up to 1 always. So 0.5, that means this is 0.5. Second part, that's if there is coach Alex, we can be also goalkeeper, or we might not be not goalkeeper. So now for coach Alex, then the probability of goalkeeper is 0.3. You are goalkeeper given that coach Alex is coaching, so this is my 0.3. And not being goalkeeper with coach Alex, both of them needs to add up to 1. So if this is 0.3, that means this needs to be 0.7. Both of them always get up to 1. Now, what is the probability that you will be goalkeeper and coach Sam is coaching today? So goalkeeper is here and coach Sam is here. So we multiply the probabilities on the branches. So then it's gonna be for part A, probability of that you are goalkeeper and coach Sam is coaching. We multiply 0.6 times 0.5, and that gives me 0.30. 0.3 or 0.30, that's pretty much the same. One more time, probability of Sam and goalkeeper, we multiply this what is on the branches. So we multiply 0.6 times 0.4. This is also, we should see it, that this is also the conditional probability. So on this branch, we have simply probability of coach Sam coaching, so probability of S. But this branch is probability of goalkeeper given that it is coach Sam. So this is probability of G given that coach Sam is coaching. So then probability of A and G would be probability of S times probability of G and S. So this is probability of S times probability of goalkeeper given that coach Sam is coaching. Let's do part B. For part B, now for part B, what is the overall probability you will be goalkeeper? Goalkeeper is right here or here. So we have two choices. We can have coach Sam and goalkeeper, or we can have coach Alex and goalkeeper. So because between them we would add it. So we can have it this branch, or we can have it this branch to be a goalkeeper, right? So probability of just goalkeeper, we're gonna have it on the first branch would be 0.6 times 0.5. This is this branch, 0.6 times 0.5. Now we say or, so we're gonna edit this multiplication. So plus, and the second branch is 0.4 times 0.3. So the 0.4 times 0.3. So if we multiply this out, we're getting 0.42. So chances of being a goalkeeper is equal to 0.42. Example 8. The probability that a randomly selected person has type 2 diabetes is 5%. If a person has type 2 diabetes, the probability that they also have a hypertension is 65%. If a person does not have type 2 diabetes, the probability they have hypertension is 30%. Draw the probability tree for this question. All right, so we can have it diabetes, or we might not have not diabetes. D stands for diabetes. Probability of having the type 2 diabetes, which we call just diabetes, is 5%. 5% is in decimal 0.05. You take 5 divided by 100, and that's my probability, right? So we have 0.05. As before, we said that they too must add up to 1. So to calculate this branch, we would take 1 and subtract this 0.05, and I'm getting 0.95. One more time, they always need to add up to 1. So one of the branches is given. The second one you calculate by subtracting 1 minus this amount. Now, if we have the diabetes, we can also have hypertension. So this is hypertension. Here would be not hypertension. H stands for hypertension. Hypertension of not hypertension. So now on the first one we have it. If the person have type 2 diabetes, then the probability that they also have hypertension, so hypertension given that they have diabetes, is 65%. So it's 0.65. As before, those two need to add up to 1. So to calculate the second branch, we would subtract 1 minus this 0.65, and that gives me 0.35. Always on two branches that need to add up to 1. Now for the second one, we also can have it hypertension or not hypertension. So then we read the data. If the person does not have diabetes, then the probability of having hypertension, not diabetes, then hypertension is 30%, so 0.3. 30% would be 0.30, which is the same as 0.3. 65% is 0.65. I hope we know. So if we have this is given, to calculate this one, we would, both of them need to add up to 1. So this part would be 1 minus 0.3, which gives me 0.7. So this is part A. Draw the probability tree. Now for part B, we look what branch do we need. What is the probability that a person does not have hypertension and does not have diabetes too? So not hypertension and not diabetes. So this is this branch, we need to multiply this out. So the probability for not H and not D would be equal to, we have 0.95 times 0.7. So we simply multiply not H and not D. 0.95 times 0.7. And that gives me 0.665. Or in percentage would be 66.5%. So in decimal or in percentage we can have those ones. Now for part C, what is the overall probability that a randomly selected person has hypertension? So hypertension, and we're looking at the branches. So we're gonna have it for part C, the branch that gives me hypertension, that's this branch, and the second branch that gives me hypertension, that is this branch. So part C, probability of H, hypertension, is, first we're gonna multiply what is on that branch, plus multiply what is on the second branch. So we have 0.05 times 0.65 plus, and then multiply the second branch which is 0.95 times 0.3. First we multiply this branch and then add this multiply this branch. Okay, and when we multiply everything together, I'm getting 0.3175. So that's my probability, or we can write in percentage would be 31.75%.